I'm going to walk through the method of sections problem that we did in class. So I'm going to start with a drawing here and make sure I've got all the geometry, the measurements, and the external forces. Make sure I understand the supports, what's at the support. So in other words, I've got a roller support at A, a pin support at H. My external forces, I've got an 8 kilonewton force acting up here at point F, a 10 kilonewton force acting here downward at E. I'm going to find the force. I'm supposed to find the force in members B, D, and CE. That's here and here. So we could use the method of joints to do this. I'm not going to, because I want to show you how to use the method of sections. But just to remind you, if you're looking at the method of joints, what we do is first find the reactions at A and at H. Once I have the reaction at A, I could look at the pin at A and solve it for equilibrium. Then I could find the force in AB and in AC. Then, once I know that, I could move to either C or B. Well, C has 4 members coming together and B only has 3, so B would be easier to solve. Then I'd go up there and solve that one. That would give me this, and then maybe I could come down and get C to get the force in CE. But a lot of steps. The method of sections allows me to do it in one piece, and the way that works is I'm going to cut the truss. Theoretically, think about cutting the truss right here along that dotted line. That way, what I'm going to do, I'm just going to use this paper to cover this up here. That's half of it. So now I'm just looking at this piece, and I see, well, in order to keep that in equilibrium, right? If it was cut, I'd have to apply a force here, and I can only apply forces along these members because they're 2 force members. They can only be in pure tension or pure compression. So I have to apply forces maybe like I've got them drawn here. They might be the other way around. In other words, my arrows might be the other way around. I've just drawn them all pointing one direction. So somehow I have to keep this thing in equilibrium given this situation. So that's the general method. Okay. So the first thing I have to do, just like with method of joints, is to find the reactions at A and at H. So to do that, I'm going to make a free body diagram of I don't worry about the internal pieces of the truss. I'm just going to look at the outside of it, the outline of it, and apply all my external forces. So I've got the 10 kilonewton, the 8 kilonewton. I've got reactions. The reason I've got 2 reactions here, and I've drawn them both positive, is because this is a pin connection. So my reference frame, I made a note of it up here. I could put it somewhere, but just to keep this area uncluttered, I just put it up here. So positive X is in the normal direction, positive Y is upward, and positive moments are indicated according to the right-hand rule. So I'm going to use that for all my algebra. Alright, so now to solve for this, I need to solve the forces in the X direction, the Y direction, and the moments all have to be 0. So the way I started this is I'm going to look at the forces in the X direction have to be 0, to the right being positive, and when I do that, I've got, this is from a previous, so 8 kilonewtons is acting in the negative X direction, so I put a negative there. I've drawn H of X positive, so that's plus HX. So when I solve it, HX is equal to K. Because these are my only 2 arrows going left and right, right? Everything else is up and down. So that's all I have. So HX is pretty easy to see. It's 8 kilonewtons, and it's going to be acting in the positive direction. The next thing I'm going to do is solve for the forces in the Y direction. So looking at my up and down forces, I've got AY, HY, and this 10 kilonewton force. AY and HY are positive. The 10 kilonewton force is negative, and that has to be 0. So I've got two unknowns here. So all I'm going to get is this relationship that I know AY is 10 kilonewtons minus whatever HY is. I know the two of them together have to be act upward at 10 kilonewtons. So that's that equation. I'm going to come back and use that. My third thing I'm going to look at is here, and sum the moments about A to be 0. And the reason I'm going to sum the moments about A to be 0 is I want to find, remember I'm looking at this part of the truss, so I could do H also, but I'm just going to look at A and just work over on this half of the truss here. So summing those, I've got the 10 kilonewton force acting downward, and that's going to be in a clockwise direction, so using right hand rule, that's negative. I've got HY, that's acting upward, that's going to be counterclockwise, so that's going to be positive. And I've got this 8 kilonewton force, again, if I think of its tendency to rotate about A, it's also going to be counterclockwise, so that's going to be positive. So I've got three forces causing a tendency to rotate about A. So when I write that equation, as I said, this one is a negative, so it's negative 10. Its moment arm is 8. In other words, it's looking at my geometry up here. It's 8 meters away. The 8 kilonewton force, which is this one, is 4 meters away. The 8 kilonewton force, its line of action is like this, right across the top here. And looking at my geometry, I know that vertical distance is 4 meters. So the lever arm for the 8 kilonewton force is 4 meters, so that's 8 times 4, and it's positive. HY is over here. Its lever arm is 16 meters, 4 meters times 4 pieces. So I've got this equation, and when I solve all of that, and I've got one unknown, right? So HY, that gives me 3 kilonewtons upward. When I solve all this, I can then take that 3 kilonewtons, put it back up in this equation, and solve for AY, so that becomes 7 kilonewtons. So that gives me my HY, my AY, and my HX. All those unknowns are now solved. And now I can go ahead and cut the truss and look at my solution. So what I'm going to do now is draw a second free body diagram. So I know that AY is acting upward. This is 7 kilonewtons. That's what I just discovered over here. The piece of the truss that I want is it's going to look like this. Now I stop right there because if you look up at this picture, here's where I'm going to cut the truss, right? Just like this. So that's it. That's all I want to draw. And I know that whatever forces are here, here, and here, and they have to act along these directions, the direction of the member itself, they have to hold this all in equilibrium. So everything has to be held in equilibrium. So I can do that. I can either anticipate which direction they're going to be, or just draw them all positive and work from there. So one of the big differences between the method of sections, which I'm showing you now, and the method of joints. In the method of joints, we look at the free body diagram of the pin. We focus on the pins. Here, we're out in the middle of each of these members, and that's what we're focusing on. So I could just put my arrows like this. This would be my force in BD. I could look at this one going this direction. This would be the force in CD. And I could draw this way. And that would be the force in CE. Now, you can draw them any way. I could draw them all positive, all negative, whatever. But here's why I drew them the way I did. The only one of these three that